Well, hello. Thank you for joining me. My name's Charlie Lees. I'm a gastroenterologist here in Edinburgh. I work both at the Centre for Genomics and Experimental Medicine within the university and also in the Edinburgh IBD unit. It is Monday, the 1st of March. This video is an update on COVID-19 with a particular focus on the new data around vaccination. This video, I am trying something slightly new technically. It's been a bit of a labour of love to get the setup right. It is quite long, it's quite involved, there's quite a lot of detail and data. It probably comes in at just under half an hour. So if you're after a detailed update of where we are with a summarizing of the data that we have in the last few weeks in particular, this I hope is a good place to start. With the caveats that here are my disclosures, including importantly the fact that I am not a COVID expert, but I have spent a considerable amount of time over the last year working in and around COVID, specifically as it pertains to immune-mediated inflammatory diseases, particularly, of course, inflammatory bowel disease, and working with the BSG and Crohn's Colitis UK to put together important guidance and a couple of important trials. So, without further ado, here is the key context that we are currently still in lockdown in the UK with a stay-at-home order, one of the toughest lockdowns across the world in the UK. But with a roadmap out of lockdown, slight differences for the four nations, but a real sense of hope that there is an end in sight. Now, this will necessarily be a UK-focused presentation, but there will be lots here for everyone, I think, across the world. I will be talking about some of the US data. I'll be talking a lot about the Israeli data. I think a lot of what I'm going to talk about is going to be very applicable wherever you are. But this will be focused in and around a lot of what we know in the UK, which of course is what I know best. So here we are with a current data cut from Our World in Data, looking at a snapshot in the pandemic where we can see, thankfully, that the rates of COVID cases are coming down. You can see them coming down from this very high level we saw in January in the US and in the UK, levels plateauing in Europe and in Canada. And some other examples here. In Ireland, the UK, and Portugal, we had very sharp accelerations in the pandemic at the end of last year, the start of this year, due to the B117 variant, the Kent variant, the UK variant, which is about 70% more transmissible than the standard COVID variant. But with lockdown, you can reverse this, and this has been a lot of hard work in the UK and across Ireland in particular. I know much less about what's happened in Portugal to break these chains of transmission. This is a lockdown effect, I'm led to believe, much more than the vaccine effect, and I'll come back to that later because that is now happening. Take a snapshot from the UK government's dashboard and you can look at positivity of tests, deaths, admissions, and tests conducted. We get an R value of between 0.6 and 0.9. And we can zoom in a little bit to see that whilst things are much better than they were in early mid-January, things are still not great. We are still seeing across four nations about 1,000, 1,100 patients being admitted to hospital with COVID every day. That means we still have almost 15,000 patients in hospital with COVID, although that number is coming down rapidly, which is great. And of those 15,000, about 2,000 are currently still on mechanical ventilation. This, I'm led to believe, is about the same as you would expect to see across all ventilated patients at any time in the UK without COVID. So it's the same. Again, it's still a lot of work. Now, this is a bit of an alarming sign in the data looking in Eastern Europe, where you can see this very sharp uptick that is in Czech, Estonia, Serbia, Hungary, Lithuania, and Poland. And this has a very similar view to it than what we saw with B117 in the UK, Ireland, and Portugal. And we know the kind of measures that are going to be needed to bring that back under control. A word about the variants. This is an excellent schematic showing the lineage of the viral mutations from The Economist just this week. You can see from the root, you go down here to the Kent variant, which has a number of new mutations. The latest theory, interestingly, is that this mutation arose in a severely immunocompromised host, where the failure to clear the virus resulted in multiple mutations happening. This has the key Nelly variant N501Y, which is the one that increases the transmissibility of COVID. This variant, the B117 variant, may also be associated with increased lethality too, unfortunately. The other two variants of concern, you get variants of interest where they need data, and then variants of concern where the data supports that, are the South African and the Brazilian, this P1 variant that we've heard about in the news just in the last 24 hours. These two have the E484K mutation, which increases antibody resistance. So this is the concern, that with these variants, you may find immune escape, that the vaccines don't work quite so well. And in this instance, they may need to be modified with booster shots later this year. That's why in the UK, we've seen this surge testing and genomic surveillance, particularly looking to pick up the South African and the Brazilian variants. So moving on to a brief summary of this, you can see in the left-hand column, the B117, the Kent variant. In the middle, this B1351, which is the South African, and the P1, which is the Brazilian variant of concern. So these two, as I say, possible vaccine resistance, which is why it's important to keep an eye on it. And this is just the news headline from the UK in the last 24 hours. There have been half a dozen cases, half in England, half in Scotland, all but one in association with recent travel to Brazil. So the surge testing with genomic surveillance, this huge work that's been done at the Sanger Institute with my colleague Jeff Barrett and others, which is of tremendous urgency now. Okay, so let's move on to vaccines then. A very brief reminder that this is the SARS-CoV-2 virus on the left that causes COVID disease. In the blue on the outside of the viral membrane, you can see the spike protein denoted in the light blue here with the hooks. When you have in the middle an adenovirus vector, you get the virus that you inject into the body to produce the COVID spike protein that the body then recognizes. In all instances, the virus here is totally inert. It cannot replicate, so it is, to all intents and purposes, dead. It then has the instruction to produce the spike protein. On the right-hand side, the mRNA vaccines, what you do on this side is that you just take the code, the message RNA for the spike protein, you inject it, having encapsulated to protect it on the way so that it gets into cells and produces the spike protein directly. Vaccination against COVID is a huge scientific breakthrough. It is extraordinary. It is perhaps a bit lucky that it works so well, but there is no doubt that this has been some tremendous advances, not just in vaccine technology, including mRNA, but genomic sequencing, clinical testing to roll out phase 3 studies so rapidly, approvals, manufacturing, scale up and roll out, etc. I have to update this regularly. I'm going to need a much longer timeline to fit this all in soon. So here is my primer of the 6 key vaccines, which I will go through briefly. This is taken from the WHO website. You can go in and dial into all the vaccines that are in clinical development, of which there are about 60, or in preclinical development, and there are over 150 there. So let's go through these relatively quickly. You've got the Oxford Astrazeneca vaccine, which is familiar to us now. In this ChAdOx vector, it's a chimpanzee adenovirus that cannot replicate. 2 doses, best given 12 weeks apart, and I'll show you later a data set that confirms that this is very most likely the best thing to be doing. The Janssen vaccine next, another adenovirus vector vaccine. This vaccine has just very recently been authorized for use by the FDA. It's 1-dose adenovirus vector. And then you've got Novavax, a slightly different one. Novavax, it's still the spike protein, but you use moth cells to produce the spike protein that's then harvested. It's studied into a matrix, and then that's injected to induce the immune response. This has also been shown to be very effective in a phase 3 clinical study run in the UK. Mrna and BioNTech Pfizer are the 2 mRNA vaccines, typically given with 2 doses 28 days apart. And then lastly, you have the Sputnik 5 vaccine developed in Russia. Another adenovirus vector vaccine, slightly differently. The vector is different in 2 different versions of this vaccine, and each individual gets a dose of each separated. The idea being here is that you minimize the immune response against the vector itself, and therefore you get more spike protein for the immune system to make its antibody response against that, which is what you desire. May also incidentally be an explanation as to why the Oxford vaccine works better given with a longer time period. My table is now very definitely supplanted by this excellent JAMA summary table with lots of detail that's just gone online in the last few days. I would recommend this. You'll see that this is more than just the 6, including, of note, I think, the CoronaVac from Sinovac Biotech in China, which is being widely used in China, and I also believe in Brazil and other parts of the world, including perhaps Turkey. Okay, let's go through the key data slides. Some of these will be familiar to you already. I have put the ones that are available together in a sequence of slides because I think what it neatly shows is how effective these vaccines are. Now, it's very, very difficult to compare any of these vaccines head-to-head because, quite simply, there are no head-to-head studies, but we can look and see that the shape of these curves is all very similar indeed. So we start with BioNTech Pfizer. We look at the placebo response here and the cumulative instance of symptomatic COVID-19 cases and the patients who've had the vaccine in the red. And the separation is very, very early, including after the first dose. So already 7 to 10 days after the first dose, you see that separation. Very similar to the Mrna vaccine. These mRNA vaccines are stunningly effective and safe. All the vaccines are safe. All the vaccines are effective. None of the vaccines have been associated with severe COVID and none with death at all. It is a tremendous success. So here's the Moderna slide. Here's the Oxford Astrazeneca vaccine. This is the original publication from the 8th of December. I'll show you some data from the follow-up paper that was published in the last couple of weeks, where there are further data points around the effectiveness of this vaccine, which works, again, stunningly well in preventing severe COVID and death. This is the Sputnik 5 vaccine. This strategy of having 2 different adenovirus vectors looks very effective indeed. Again, this is the key take-home slide from the Lancet publication there. And then lastly, we've got the Janssen COVID-19 vaccine from Johnson & Johnson. This vaccine hasn't been fully published yet, but the data have been released with the FDA application, which is all in the public domain. And this, again, is the key slide looking and showing how this 1-dose adenovirus vector vaccine, again, is extremely effective indeed. And this has now been approved by the FDA. So here we are. We have these different vaccines. How then to vaccinate the world? The experts say that no one is safe until everyone is safe. No one is protected until everyone is protected. Why? Well, quite simply, if we vaccinate everyone in the UK and everyone in Europe and everyone in the US, etc., but we don't vaccinate everyone else, then because COVID is really endemic already, what we see is that in other parts of the world there will be increasing evolution of the virus with increasing immune escape. Our vaccines will no longer work for anyone, and then we may be at risk of being back to square one. So it's much more effective if we vaccinate the whole planet and work towards a very much more controlled situation, even if elimination is not possible, as the experts tell us. So let's have a look at how we're getting on. This is total or cumulative vaccine doses administered. You can see the US out front here, then China, European Union, UK, etc., etc., etc. So that's interesting to a point, but when you look at the world, you can see that, okay, things are going up. There's a long way to go. You know, there are, 7 billion people on the planet. We're at 250 million vaccine doses so far. There is a long way to go yet. This is perhaps easier now to look at when we come to country by country, when you control it per 100 people in a population. And here, what you can see very clearly is just how far ahead of the pack Israel is. You then see the UAE, which is an interesting Outlier, I think, because in the UAE, any adult can come forward and get vaccinated. There isn't being any prioritization from what I understand, and there may be a degree of vaccine tourism in the UAE too. UK, US, and then this stunning response from Chile just in the last month. And then you can see some other big nations here with large populations to vaccinate. Of course, the world is here for context too. Vaccinating the world requires support and a program that is coordinated to deliver not just money, but vaccines to low-income and lower-middle-income countries. That scheme is COVAX. COVAX has lots of money pledged to it by rich nations, but it doesn't yet have lots of vaccine doses. It was gratifying to see the first doses delivered to Ghana last week. This was the Oxford Astrazeneca vaccine, manufactured and produced in India and shipped to Ghana. It's a start, but there's a long way to go. What COVAX needs is vaccines as well as the money that's been pledged. One country that has had plenty of vaccine is Israel. Israel, we understand from reports, paid a very high price for access to the Pfizer vaccine very early, but also in return for data to support its rollout and its use, its real-world vaccine effectiveness. And boy, have they produced some stunning data. Huge amounts of data publicly available that we can start to look at. So I'm going to go through this in a bit of detail because I think this gives us our first really good guide that these vaccines work, and they work stunningly effective. And importantly, that they are safe. So this is data already from the 3rd of February showing cases and hospital admissions. At this point, 60 plus age bracket was largely vaccinated, but those younger were not. And you can see cases dropping rapidly, but not in the younger age group, as well as hospital admissions. This gap here is the vaccine effect, and we'll come back to that in some further graphs. Now, since then, in the last month, the Israeli team have vaccinated nearly 100% of the 60 plus population with both doses now. You can see light blue is the first dose, dark blue on the top right is the second dose. Very nearly everyone, again 50 to 60, and you can see how progress is being made in the 40 to 49 bracket and the 20 to 39 bracket too. So now you can look at what's happened in terms of new hospitalizations over time in the over 60s and the 0 to 59-year-olds, and you can see this vaccine effect there. You can observe this again if you look at severe COVID by age, where there's been this high spike in the over 60s that has dropped very, very much more rapidly, with only just a slight recent tail off in the younger age group. And then a slightly different way of looking at it is comparing geographical regions of Israel where there's been early vaccination success versus late vaccination. And you can see that even in the early vaccinated over 60-year-olds, the rates are now much, much lower. This is hospitalizations compared to the late vaccinated young and old people too. So evidence that it's working. And in fact, now the Israeli team have published a very detailed analysis in the New England Journal of Medicine last week, where they've compared a large number of vaccinated people with a matched cohort that are unvaccinated, over 500,000 individuals in each group, and looking at documented SARS-CoV-2 infection, top left, panel A, panel B, top right, symptomatic COVID, panel C, middle left, COVID hospitalization, D, middle right, severe COVID, and at the bottom, death. So we can look here at these middle panels. So the red line is the proportion that are unvaccinated, and you can see the clear separation very early after the first dose, like we saw in the phase 3 data versus those that are vaccinated for hospitalization and severe COVID, as well as for death. So this vaccine works stunningly well. It is the Pfizer vaccine, BioNTech, along with Mrna, and soon to be the Janssen vaccine that is being rolled out in the US. The US has accelerated its vaccine program very rapidly indeed, as both Pfizer and Mrna have scaled up their production. All the vaccines require a significant upscaling of production to vaccinate the planet, but it is happening, I think, quite quickly now. 2 to 2.5 million people vaccinated every day for the last 3 days in the US. And what about the UK? Well, this was the news from last night, when over 20 million people have had their first dose across the UK, which honestly is very gratifying for us. I don't want to get into any kind of vaccine nationalism here, but we've had a really tough pandemic here in the UK, and I don't pretend for a minute that we're the only ones that have. So it is nice from our point of view to see this rollout going very well. I know a lot of people work very, very hard to make this work. Important caveat, of course, is that there is this long delay, this 12-week delay between first and second doses, so there is still a lot of work to do. The UK government website shows us where progress has been made, and you can see here the cumulative number of first doses in the light blue in England, yellow Northern Ireland, dark blue Scotland and Wales. On top in red, perhaps reflecting the rugby result yesterday. Unfortunately to me, as an Englishman living in Scotland, that was not a happy moment. So that's the first dose cumulative. These are the daily doses. And again, very successful rollout, nearly always above 300,000 a day now, often hitting 500,000. But as I said, we need to start giving people their second doses. It's very important that we get these second doses, particularly out to the older, most vulnerable people, as we continue to roll out the first doses. And this is what you see here when you look at the second doses daily being given across the 4 nations. So, a word more on this. This is how the vaccine rollout has been delivered in the UK. It has been delivered under the guidance from JCVI, and JCVI has given the risk groupings and the order in which to do it. The first 4 groups, very familiar, starting with older care home residents, care home workers, people aged 80 above, then 75 to 79, 70 to 74, and the clinically extremely vulnerable people, which equates to the people that we're shielding, which equals those people with inflammatory bowel disease who were in the highest risk of the BSG grid that we generated and published last year. These people all had their first dose by mid-February, and all the modelling data that I've seen in the last couple of weeks and published from what, the way I understand it, confirms that this is the right way to prevent severe COVID and to prevent deaths. We're well in the UK under this part now. People between 60 and 69 being vaccinated now, including those aged between 16 and 64 with underlying health conditions. This is the clinically vulnerable group. That equates to JCVI category 6 and the moderate risk from the BSG grid. It should be soon that the 50 to 59-year-olds are called. And then for the rest of the adult population, the decision has been made and announced in the last few days that it's going to go 40 to 49, then 30 to 39, and then 18 to 29. And the reason is very simply because, one, this is simple, it's easy to roll out, and it likely follows on the huge success already seen, where if you go for a simple age-based rollout, by and large, as well as picking up the vulnerable people clinically, you will reduce mortality and severe COVID the quickest. So here we see the data from ICNARC, which is critically ill patients with COVID, split by age and sex. And it's very clear to see that if you look at those adults under 50, it's men who are between 40 and 49 who are at the highest risk. But even with females, the risk goes up with age. So if you're a younger teacher or a younger policeman, you are clinically vulnerable, you should have already been vaccinated. If you're not, then your risk is very low indeed. Many of the high-risk occupations we know, like industry workers, people in meat and other indoor factories and transport, are concentrated in this high-risk male 40 to 49-year-old bracket. Okay, a few other data points on vaccines before we finish this section. This is the updated Lancet paper looking at the Oxford Astrazeneca vaccine with many more data points and slightly longer follow-up. And what it's able now to show very clearly, I think, here is that vaccine efficacy on the y-axis increases significantly dependent on the duration of the gap between dose 1 and dose 2. So when you get out to 12 weeks, you see the vaccine efficacy going up significantly. And additionally, what you saw from this paper is really very strong effectiveness already from that first dose of the Oxford AstraZeneca vaccine. Another interesting question that's come up recently that I think is still to filter through to guidance is what do you see in people who've already had COVID? How do they mount a vaccine response compared to people who haven't? Do they still need to have both doses of the vaccine? Well, everyone who's previously had COVID definitely needs to get vaccinated. If you've previously had COVID, your pre-vaccine levels are here in the light blue on the right, and they go up very high after vaccine, higher than those people who were unaffected. The suggestion here is that actually people who've been previously infected may only need one dose, particularly the mRNA vaccines, because that's where this data is. There's another data point here from another Lancet correspondence recently showing this again, very much higher levels of anti-S antibodies, anti-spike antibodies in people with previous natural COVID infection. So this is an interesting thing to keep an eye on. For now, if you've had COVID before, you should go ahead and get vaccinated as soon as you're called, absolutely, and still get 2 doses unless that guidance changes, which it might, but we'll just need to see. There is also now good evidence emerging from the UK of the vaccine effectiveness. So similar graphs to what we saw earlier from Israel. Again, these initial beautiful graphs from the FT, from John Byrne Murdoch, who I recommend you follow on Twitter for very frequent updates here. You can see cases, hospital admissions and deaths here when you compared the initial group that were vaccinated, the 80 plus, versus younger adults. You can see the vaccine effect there, I think, very strongly indeed. In Scotland, there's been a very nice paper published as a preprint just so far from Aziz Sheikh and others from Edinburgh, looking at the effectiveness of one dose of either Astrazeneca or Pfizer-BioNTech in preventing severe COVID and death. And it shows very neatly that both of these do with just one dose. And this is in a population, as you can see here, who in an older age range have had very high numbers of both of the vaccines, including the Astrazeneca vaccine. There has been some discussion on the continent as to whether or not the AstraZeneca vaccine works in older people. I think there are multiple data points now, including this one, that shows very clearly that yes, it does, just as the MHRA and the EMA said that they believed it would. So would encourage older people to get vaccinated with whatever vaccine they are offered, absolutely including the Oxford AstraZeneca vaccine. Okay, so a final couple of minutes just to summarize where we're at with COVID vaccines and IBD. There's nothing much to say differently from when I last put this out, but I just want to summarize the key points again and point you to the Facebook Live that we did that's still up on the Crohn's and Colitis UK website and on YouTube with Nick Powell and Seb Shadji and others there. This is the BSG guidance document that Nick Powell led, that we all contributed to from the BSG Clinical Research Group and IBD section, with these key messages. We strongly support SARS-CoV-2 vaccination for patients with IBD. The risks of SARS-CoV-2 vaccination in patients with IBD are anticipated to be very low. At the same time, there was the IOIBD consensus group that met and published in Gut. Very, very complementary, similar messages. Their key points are very nicely worded too. Patients with IBD should be vaccinated against SARS-CoV-2. The best time to administer SARS-CoV-2 vaccination in patients with IBD is at the earliest possible opportunity to do so. SARS-CoV-2 vaccines, including the mRNA vaccines, replication in competent vector vaccines, inactivated vaccines, and recombinant vaccines are safe to administer to patients with IBD. And please do not defer vaccination because a patient is receiving immune-modifying therapy. And please also do not stop therapy to allow someone to get vaccinated. Both should continue. Patients can get both on the same day if they need to. So that's just about it. There's a huge amount of good information if you're a patient or a healthcare professional in those two publications as well on the Crohn's and Colitis UK website with an excellent FAQ. So I'm just going to finish again on a very positive, upbeat note about the success of vaccination in COVID-19 disease. This is from Our World in Data. A lot of the graphs I've generated for this have come from there. And what it shows you is how vaccine innovation has shifted over time. And where we still have an open case, like malaria and TB, where we've been trying to find a vaccine since the 1880s and still have not. Slightly more recent examples, like HIV, which we still haven't vaccinated. Some earlier success stories, of course, like polio, My uncle had polio in 1953 or 4. I think he was one of the very last people to get polio, unfortunately. And I saw firsthand the effect that has on an individual. Polio has been stunningly successful. Measles too, hepatitis B, and now we can add to that list COVID-19 vaccinations against SARS-CoV-2. So that's it. If you've made it this far, well, congratulations. Thank you for your attention. I would love to be able to do a live Q&A just now. Of course, this format doesn't work for that. If you have any questions, please don't hesitate to get in touch. I will aim to come back with further, briefer, more pointed updates in due course. In the meantime, please stay well, keep safe, be kind to yourself and others. Thank you very much. Goodbye.